welcome to trigonometry, that one class with the shapes and stuff. That's your
Okay. That's a good effort. Good effort. All right. Anyway, so we're finishing tangent and cotangent. So for all those people that didn't pay any attention to anything because they were on their phone and couldn't even do the warm-up today, so now's the time to pay attention and not have something thrown at you because I'm that angry because you don't pay attention. Yes? In that box over there. Okay. So we have a couple things that a lot of people did not have for some reason. So asymptotes. You know what? You guys remember how I drew it on the board and my board was lagging and it said ASS, and then everyone laughed about that. But as I tried to list it, no one wrote down anything to do with that.
What? Asymptotes.
Yes, I just spelled it instead of saying it. Thank you very much for captioning my angst right there. All right.
That's my senior quote.
You know how to read, Leslie.
Tangent. Tangent. There are natural asymptotes at a couple places. Okay? They're natural. We manipulate them with phase shifts, changing the period, changing all kinds of things. So we're going to start this. So tangent has at negative pi over 2 and at pi over 2. You need those things to do your math. If you do not write them down, you're going to come back to me tomorrow and say, I don't understand any of these notes. Listen, my guy, my dude, okay? I don't want to hear any of that again, please. All right. Now.
Where are we even at?
Room 704. Thank you. All right. There's tangent. Next one's cotangent. Cotangent has natural asymptotes at 0 and pi. Now, what is the period supposed to be for these two things right now? Pi, right? Because sine and cosine is 2 pi. Thank you. Sine and cosine is 2 pi, but tangent and cotangent are? Thank you. So, one person paying attention. Thank you. I appreciate that. Okay. All right. So now that we have these right here, so now I'm going to start with a couple things. Step 1. What's the first thing I'm going to do? Amp. My amplitude is what? 1/2, right? Period is going to be what? Pi divided by? Where'd the 2 come from?
2x.
Very good. 2x, right? It's from that one right there. So my period is now going to be 2. Now, I'm going to start with my asymptotes. Which ones am I going to use here?
Isn't it
Cotangent?
something?
Negative pi over 2.
Right? Oh, it's pi over 2. Something like that.
0 and pi.
I don't know, man. A little.
0 and pi.
0 and pi. 0 and pi. It's almost like I should just write it on the board for some reason. Okay.
Did you get that again?
It's on
Huh?
the board.
Did you get that?
Where did I get that?
Yeah.
From the unit circle.
Okay.
Because cotangent is cosine over sine, right?
Yeah.
Cosine over sine. And at here and here, at 0 and pi, is where sine is equal to 0. When sine is equal to 0, that's going to give me my asymptotes.
Okay, so sine has to equal 0.
When sine is 0, because cotangent is cosine over sine.
Okay.
And you would have 0 in denominator. I cannot have 0 in denominator.
That's undefined.
That's going to be your asymptote here. Now, for tangent, it's sine over cosine. These two places are where cosine is equal to 0. Yes? Okay, good. All right, so asymptote. So, which ones am I going to use?
0 and pi.
Thank you, 0 and pi. 0 times.
Pi over 2.
Okay, so it's going to be 1 over b, right?
Oh, okay.
1 over b, 1 over my b value,
2.
which is 2.
But it's going to be undivided because it's times
No. I do reciprocal if I have a fraction.
What do you mean? Isn't that a fraction?
Okay, what is the b value?
2.
And this right here is 1 over b.
Oh.
So 1 over b. So this is 1 over b. So my b is 2. So it's just going to get that, right? Yes, very good, right? Yeah, unfortunately. All right, so that's going to give me 0. Yes?
Yeah.
So I have an asymptote where?
0.
Thank you. My next one, I would start off with what? Pi. Times 1/2. 1 over b, right?
So it's gonna be pi over 2. Yay, we did it.
There we go. So I have my asymptotes. Okay? Those are the asymptotes. So when I graph it, I'm going to have those. So now the next thing is, I'm going to show you the parts now. For the parts. Okay? So I know I have an asymptote here, right?
Yeah.
Okay? So that's going to be my starting, right? That's where I'm starting at.
Yeah.
Okay? So it's going to be 1/4 times, what's my period?
Pi over 2.
Okay? There is no phase shift, right?
No.
So I'm going to end up with,
Pi over 8.
next one's going to be
1/2.
times
So pi over 4.
3/4 times is going to be,
3 pi over 8.
there we go. So these are my pieces in between my asymptotes. Right? Okay, so
Wait.
We graph it.
Wait.
now I'm going to graph.
Wait.
Wait.
What do you mean wait?
I was copying down the
You gave us
notes.
like 0.2 seconds. This is kind of hard.
Well, yep.
So for the parts, we don't have to do one number?
Is that
Because it's
5 or
0
8?
through pi?
Okay, so if I do 1, where am I going to end up at? I should end up at my other asymptote. So I do my asymptotes first.
Those only 2 asymptotes.
So it's going to be between these 2 asymptotes here.
Alright.
I feel like this is wrong.
I still don't get it, but you know.
Yeah.
What's wrong?
I don't like. Alright, so like, why on the first time that you did this, that you had like, what was it, 4 asymptotes?
I had a whole bunch because I was doing it the same way I was showing you guys before. But because I had my asymptotes, so I showed you asymptotes last time.
Yeah.
Right? I went through, I showed you asymptotes, and I showed you if I keep doing my parts, all my parts through there, I would find 2 asymptotes, right?
Yeah.
So, and if I did my quarter and all that other stuff, I would get my asymptotes if I do enough of them. But instead of actually just doing parts and finding asymptotes in between here somewhere, we go straight to the asymptotes and start from those. So I kind of streamlined what we do. How?
Yeah.
Did you were you watching when I actually started with this?
I did, but you know, I can't listen, right? So, you know, I can explain it again. I'm a slow learner.
Okay, now I will. So just make sure you hit like the back arrow or like refresh when we get through it again.
Alright.
Asymptotes start here.
Okay,
These are my
where'd you get
parts.
those?
Huh?
Where'd you get those asymptotes?
These ones right there.
From the unicircle, right?
Yes. And I'm telling you, these are always there. These are where they naturally occur.
But they're not always going to be there on a graph?
They're not always going to be there. Why are they not always going to be there?
Oh, cause
Alright.
Because I'm changing it with this, right? And sometimes I'm going to have a phase shift, which is going to move it left and right.
Where? On here.
Remember when we were talking about this a minute ago?
No. That's the problem.
When we were talking about what's cotangent?
X over Y.
Okay, x over y. Cotangent is x over y.
Okay.
And for it to be undefined,
The Y has to be 0.
okay, so now on your unit circle, tell me where is
Right here.
the y value equal to 0?
Okay.
That's an asymptote.
That's an asymptote.
When your y values equals 0, that's your asymptote.
Oh, okay.
Lost.
And then the tangent when the x is 0, right?
Yes.
So that'll be what?
Oh, so that's like from top and bottom?
Hold up.
Top and bottom would be like tangent, and left and right would be cotangent.
Oh, okay.
Okay.
Wait.
Wait, no.
Alright,
I
so
kind of get it now.
which one would be the tangent? The pi over 2 or the 3 pi?
It's not 3 pi over 2 because we're wrapping around this. So we're doing pi over 2 and I'm doing backwards.
Our brains are
So instead of
dying.
going pi over 2, then going to 3 pi over 2. Because that means I'm going to shift everything over this far. I just want it around
You
the
guys don't know
axis. So
this.
here and here. So going backwards, negative pi over 2.
You should need your
Okay, let me come back to this, alright? So I kinda alright, so now I got my parts. So let's take a look. So on my graph, I have this is gonna be 0, right? I know there's gonna be an asymptote there. Where's my next one? Okay, my part's in between. This part's gonna be what?
Okay, now I'm.
What's my first part? Pi over 8.
Pi over 4.
Pi over 4.
3 pi over 8.
There's my parts.
Wait,
Bless
so
you.
far, thank you.
So, asymptotes. I'm going to draw a dotted line for my asymptotes. Bless you.
Why are you drawing?
Why am I drawing them there?
Because that's the asymptotes.
What are these things right here that I just spent a couple minutes?
I know that.
Well, like why?
No. I'm confused because you says that it's going to be negative pi over 2 or pi over 2 and 0.
What did we do
That's for tangent.
here?
What would you need the tangent? What's the tangent for?
Oh, never mind.
Tangents for your notes. Because this is what I was telling you guys on Tuesday. You have asymptotes that start here and here. Is this a tangent problem?
No.
This is a cotangent problem. So which ones am I going to use with cotangent? 0 and pi.
Why didn't
0 and pi.
But why did we get like a different answer? I thought it was going to be like 0 and pi every time.
Now, is there a change to it? Did we change it?
No. No.
We didn't change it? We didn't multiply by 1 over b?
Oh yeah, we did. Chill out.
Because that's the 2 in front of my x.
I just meant the phase shift. That's why.
No, there's no phase shift. No.
Alright, I kind of get it. I just need like another help.
Okay, it's fine. Okay.
Let's keep going.
You know, I'm like getting worried because like someone's like not paying attention right now. In like 2 minutes, they're gonna ask me where that came from. So these are our asymptotes here and here for this problem because I did this. I changed the period. So I changed the period with the 2 in front of my x.
Okay.
That changed my period, so it changes where my start and finish are. So my 2 asymptotes, it's changing those. Yes.
Oh,
Alright,
okay.
so you said how you're live streaming this, right? They can only see the board and not you.
I'm not live streaming, but
You're recording,
yes.
so they can see you.
No.
No.
Or not.
No, it's just only.
They're recording.
Only the board.
It's only
But it has
Also,
a
it's
mic
like
so they can
screen
hear.
recording.
Yes, it's screen recording.
Oh.
Alright, so
you got the
I can go back to this, right? Later on
Yes.
today, watch
Yes.
this,
You're barely recording.
and we can hear everything.
Oh.
Yes, all this conversation that's happening right now,
Oh, I get it.
instead of the math, is yes.
So this is kind of helpful, right?
Oh, sweet baby Jesus.
No, like breaking it down.
Huh?
Breaking it down for like the millennials.
That's why I always end with like and subscribe for all those millennials, right?
Yeah.
Anyway.
Generation.
Wait, hold on. Wait, you guys are millennials.
No.
You guys are born on this side 2000, whatever that
What does
means.
that mean?
I don't know, whatever it is.
What does it say? What
Huh?
does it say?
We're sent 10
What are
years.
we?
Okay, listen up.
Generation.
Is it like the next generation?
Now,
That generation?
for this one right here,
That's scary.
hey, shh,
Sorry.
squirrel. Now, for this problem right here, it is a cotangent, right?
Yeah.
What is my amplitude?
1/2.
1/2. So that means it's going to go up
1/2.
and it's going to go down.
1/2. -1/2.
There we go. So let's see right here. I'm going to mark my 1/2 here. I'm going to mark a 1/2 here.
And that's where cotangent starts, right? Is that 1/2?
Now, okay, tangent goes which way? Up or down?
Up.
Thank you. It does. It goes up. Tangent goes up. Okay? And cotangent is reciprocal of that. So cotangent goes down. The only thing that would change that if I have a negative in front of it, and that would change the direction. But cotangent, it's positive cotangent, so that means it has to go down. So a couple places. So I'm going to start here, right in the center. Okay? That's where my point is going to be. And then tangent, cotangent, so this is where it changes. So since this is cotangent, the left side of this has to start, say up. Okay, it starts up right here. And then my right side is going to go down right here.
And it makes a swirl. Oh my god, that one looks good, Mr. Pacho.
You know what's sad? I actually was practicing this.
You were?
Were you really?
Yes.
Aw.
Anyway, alright. So this is what...
Sorry.
That was gross.
There goes
Every time I see your homework, I think the same thing.
Oh.
That's sad.
I think so.
I know, but it's very rarely I see it, so I can't see it. Anyway. Alright, I still love you though. Alright, anyway,
Just stop. No.
right here. Does this make sense now? Is it, you guys understand why I do my asymptotes? Because it's going to be between, everything tangent, cotangent is between the two asymptotes.
Okay.
That's what you started in 5 over.
That's where I started because I started with my asymptotes. Okay? And then I find out my parts in between.
Okay, so what you're saying is that if it was negative, right, the negative 1/2, what you would do, right, it would be just like,
Okay, hold on, yes. If this was a negative cotangent, cotangent goes down. But the opposite, so negative cotangent would be the opposite, means it would go up.
so that means tangent is going up.
Excellent, exactly what I said.
Alright.
Oh my goodness.
There we go.
Can we do another one?
So the period is like the end of the graph.
Yeah.
Okay.
Hell no, what is that?
So, hey, look at that. It's all pretty. It looks just like mine, right?
We did.
No, that one-
Huh?
So you know how we got other parts like 5, 8, and like.
Yeah, and that's these pieces in between.
Yeah, but why did we do it on the 5 or 4? Like just like because it goes down with the graph. What do you mean?
What do you mean?
It's parts. The parts.
That's one of my parts. That was the 1/2 part.
No. Why is there a point on it?
Yeah, but no, yeah, like.
Well, that's
so
just how you
there's,
make
like,
the
there's
graph.
other parts, but there's no down on those. But why?
Yes, they are.
No,
Where-
there isn't.
Yes, they are. But the point, look, the point's right here.
Oh.
Okay.
Point's up here. Point's right here.
Oh, okay.
Make sense?
Yeah, I got it.
Okay.
But how do you know where to put those dots?
Okay, so you start with the center. Start with the center. Center's going to be in the center, right?
Yeah.
Okay.
It's like,
So right there. So now then it goes by the shape. We know the cotangent goes down. So reading it from left to right, if cotangent goes down, that means the left side has to be up and the right side has to be. So that's where I get that point and that point there.
Alright.
okay.
Alright.
That
My
was
gears are grinding now. I can like
Okay.
process it.
I had a question, but I lost it.
All right, let's try this one right here. Let's see
Do
it.
This one nice and slow.
Like,
With
break down
like
the steps.
Step number 1.
And then break it down to 2.
Okay, let's try this. Okay, step number 1. Uno.
Well, you lost
And
me.
talk slow, don't talk like hella fast.
Well, definitely watch the video and rewind it.
I think that's
The very first step of this problem, I'm going to start off with doing the what class?
Amplitude.
Thank you.
Amplifier.
My amplitude of this problem is going to be,
1.
where'd the 1 come from?
In front of the tangent.
There is no number in front of the tangent, so therefore that is my number. The number is
1.
Oh.
But wait, Mr. Pacho, we have a vertical shift.
yes. But that is not step 2. We're starting with step 1. So step number 2.
Period.
we asked for it.
I'm actually
Step number 2 is period.
I find this very helpful, so shush.
Now, when I'm starting with the period,
Okay.
what number goes on top?
2.
Two.
Pi.
Pi, because tangent and cotangent always start with
Pi.
thank you.
So it would be pi over
2.
1.
One.
Wait, where'd the pi come from?
Oh my god.
Please.
Tangent and cotangent,
Where did 1 come from?
tangent and cotangent. Sweet baby, okay, so always start with
Pi.
For cotangent and tangent.
sine and cosine.
Start with 2 pi.
2 pi.
Oh, but I thought it was like 1 over b.
Yes, but not yet.
Oh.
Okay, now what is my b value in this case?
1.
I hear 2 and 1.
It's 1.
It is going to be 1.
That's one.
The b value is the number in front of my
Wait,
x.
this isn't pi over 4. I think I've been doing the wrong one. Give me a minute. Wait, what page are you on?
The one that says example 4?
I don't have that.
Flip the page.
I did, and it says like pi over 4 over x or something.
Oh my goodness.
I didn't do this one.
You're on example 5. 4. This one says 4.
That says x.
Example 4.
Okay.
What?
Alright, step number 3.
Step number 3. Okay, step number 3. Does this one here have a phase shift?
No.
Yes,
No.
sir.
A
Wait, no.
spaceship.
No.
Phase shift is the shift left and right. This part of here, right here where the x is there something parentheses that is moving it left and right?
No.
Sir.
So that is going to be none.
Okay.
Now, let's take a look at the next thing. The next thing is going to be my what?
Vertical shift.
Thank you. Step number 4 is my vertical shift. For this problem right here, class, my vertical shift is
2.
Thank you. 2 is the number. The number is 2. Where did that number come from?
In front of the.
C
In front of the 10.
Okay, it's almost like I have a format of my problem here where it would be this number over here, which is my C value.
Oh.
Yes.
Yeah.
So
Now,
interesting.
On a tan and cotangent problem, the next step, step 5, would be what?
Find the
Nani?
This is where you gotta talk really slow.
Right now, I can get down like.
Not high pitch, just slow.
Time for my asymptotes.
Asymptotes.
Alright, asymptote. Tan.
No.
Now, this is a tangent function. Class, where do my tangent functions have their asymptotes?
Negative pi over 2.
Pi over 2.
Pi over 2.
Negative pi over 2 and pi over 2.
Now, Miss Master Poncho, sir.
Senpai Pacho. Watashi
Listen, thank you. You're right. My nose of it.
Did you write down when I told you, because I put it on the other slide, telling you to write it down? You have lost all privilege to talk. I asked you, write it down.
What was I here?
You were standing right there and you had me back to talk about it.
Alright, ignore me. My bad. Keep going.
I'm glad your mom is watching this video right now.
Oh, she is.
Yes.
Maybe she can teach me.
You know what's funny, because I actually did send her the link for this. Anyway, alright, so I have my asymptotes here and here for tangent, right?
Yes.
Okay, so given this right here, I'm going to multiply by 1 over
B.
B.
Yeah.
1 over B.
1 over 1.
1 over 1, thank you. 1 over 1, right?
Yes, sir.
There we go. So this is my step, 1 over 1, because my B value is 1.
So it's gonna be negative pi over 2.
Okay.
Yes, it's the steps.
Step number 6.
Class, step number 6. I would call that my what?
Your parts.
My parts, thank you.
Your body.
My parts. So,
No, that part.
now, so, I'm going to do 1/4 times my period.
Which is 1 over
Pi over 1.
It's just going to be pi, right?
Yes.
what?
Yup.
Okay. Now, I'm going to change up this one right here. Now, this one's going to be plus.
What?
No, it's not the vertical shift because vertical just moves up and down. This is actually affecting my left and right. So it's plus my start.
What do we start at?
Okay, you start at your first asymptote. Where is my first asymptote?
Negative pi over 2.
There we go. So this gives me my first asymptote, also known as my start.
You didn't tell us that.
Ah, you're right. That's why it's part of our notes.
Right, so what was that? One part,
So
period.
so we just replace the phase shift with that.
Where it's going to start. You'll see. Because tangent, cotangent, there's a reason why we have a section just for tangent and cotangent.
Is it okay to write pi over 1?
Yeah, it is.
I mean,
It's fine.
the same thing.
Now, my start is going to be,
Negative pi over 2.
oh, negative pi over 2. I'm sorry.
Jeez.
I got too carried away on this.
So then what?
All right, so next one's going to be 1/2 times pi plus negative pi over 2. 3/4 times pi plus negative pi over 2. So this is going to be pi over 4 minus pi over 2.
Wait.
So that's going to give me what?
Pi over 2.
2 pi
1, 2 pi minus 4
minus 1 pi
over 8.
So that gives me, do your math, negative pi over 4.
Okay.
Do the math here, right?
Why couldn't we have just left it at
Wait.
then why?
Alright.
2
Oh, so
pi
you reduce.
minus
Yes, I reduce it, okay?
4 pi minus-
Because it's 2 pi minus 4 pi over 8.
Oh,
So it's negative 2 pi over 8, which is negative pi over 4. Okay, next one is going to be pi over 2 minus pi over 2, which gives me, my next one's going to be 3 pi over 4 minus pi over 2, 6 pi minus 4 pi over 8. So it's going to be 2 pi over 8, which is
pi over 4.
pi over 4.
Wait, show.
Stop the thing.
What?
Show. Wait. Go down.
Why what?
Why are you subtracting stuff?
Because there is a plus, a negative here, because my start is here, a negative pi over 2.
Yeah. But you didn't do that with the asymptote last time.
Okay, because there I didn't have anything with this. This one actually, my cotangent started at 0.
Yeah.
So it didn't move anything at all.
Yeah.
So my
This is
start was
because-
0.
So this is because of the vertical shift?
This is because it is tangent, and tangent starts at a different place than 0.
So you subtract
Tangents-
it by the first one and then you
Yeah.
do it?
Yeah.
Basically?
Then
with
you
the
start
other
you
one?
start with this one right here. So you add your start. But on the other one, my start's going to be 0. And this one, and it didn't have any phase shift. So we ended up just going with the same thing.
Okay.
So now I have my asymptotes and I have my parts in between.
Wait, isn't it?
So what's step number 7?
Step number 7 is graph.
Wait.
Why is there 3?
Go back.
They graphed it already. So your asymptote we said was negative pi over 2, right?
Yeah.
And pi over 2.
Okay, and pi over 2, right? So all I'm asking is for you guys to just do this one right here, right? Now, for this one right here, my vertical shift is 2, right?
Whoa.
So I'm going to do a dot going this way. Right?
This is step 7.
Is this 7 or 8 or 9?
I don't know. What would...
This is
7 graph.
7 is graph.
Alright.
Thanks.
Okay, so now, because of my vertical shift, it moves it up, doesn't it?
Yeah.
So it moves the whole thing up too. So I'm going to put my dot in the middle there.
Okay.
So this point right here would be what? What was my first part?
Negative
Negative pi over 2.
Pi over 4?
Yeah.
Okay, and my next one's going to be a positive
Pi over 4.
0.
pi over 4, and I had 0 right here, right?
Yeah.
But why do they have 3 lines?
Because they graphed it 3.
Oh,
I don't know. I just used the graph that they already had there because theirs is nice and pretty and mine's aren't.
So when we graph it,
1.
we only have 1
1.
line.
I'm asking for 1. Okay, so now that you have your parts right here, right? So, I have this right here, right? What was my amplitude?
Was it 1?
It was 1. So from my vertical shift, I go up 1,
Down 1.
and I go down 1, right?
So 1.
So, this is tangent and it's positive, right?
Yeah.
So tangent being positive
Starts off on top.
starts
On bottom.
starts bottom and ends up, right?
Yeah, my bad.
So therefore I have a point right here, and I have a point right here. So this is different than what they have. They just have the graph without their points. So here is our points that we have. So at negative pi over 4, it's down, so it's at 1. And at pi over 4, it's up 1 at 3. A little bit more sense? No?
Good.
I don't understand the
I
graph.
like your line.
Thank you. Kind of cheated because I just, traced. Make sense? Kinda?
I'm at a 2.
You're at a 2?
Yeah.
Okay. So we'll pull it up to like a 3 or 4 after you watch the video, right? Okay. So I'm gonna stop right there. Please take this time today. Don't just sit there and like text message people and play on your phone and complain that you don't get it and not write down the notes
Dude,
and
I
say,
get it.
I don't get the notes.
Dude, I wrote down all of the freaking notes.
Thank you, dude.
So shut.
Thank you, my dude. Okay, so you guys please, like I said, come in today during advisory. You know what, work on this, graph this. You have to practice it to be able to understand it.
I get
Okay.
depressed whenever I come into your advisory.
Today is Thursday, yes.
Oh, after that.
Okay, are we good? All right, go ahead. Emmanuel, close us out.
Like and subscribe, 20% off merch.
Did you just say